All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistical Solutions. During today's presentation, we will be discussing how to confidently conduct and write your power analysis. So this is primarily a quantitative topic. We'll be discussing the different softwares you can use to conduct your power analyses. I will be showing you two softwares. So if you have any questions, you can type them into the chat box. My colleague, Melissa, is assisting me today with questions during the webinar. And at the end of the presentation, I will be doing a Q&A session that I can cover specific questions about today's presentation. So I'll start out by giving a brief explanation of the services that our company Statistical Solutions provides. And then we will discuss the different components of our analyses. I will show you a demo in Intellectus statistics, as well as GPower, which is a pretty popular tool for developing a power analysis. And then we'll conclude with a summary and a Q&A session. Our company, Statistical Solutions, provides assistance with every part of the dissertation process. So we assist with both quantitative and qualitative dissertations and theses. We have specialists here who focus on quantitative, qualitative, mixed methods, and we have literature review specialists as well. So going from topic development, developing research questions, hammering down a theoretical framework, finding literature to support your topic. We also help with data analysis plans, so figuring out what are the ideal tests to address your research questions. We can help you find survey instruments online that align to your topic. We help with data entry templates, uploading surveys onto SurveyMonkey, both quantitative and qualitative results chapters, as well as the discussion chapter, PowerPoints for proposal and final defenses, and journal publications. So if you've hit a roadblock in your dissertation and you feel like you need some assistance or guidance, please give us a call at 727-442-4290. So as we dive into the topic today, it's first important to understand why the sample size is so vital to quantitative research. The ability to find statistically significant results is highly contingent on your sample size. So the higher your sample size is in quantitative research, and you're running inferential statistics like regressions, t-tests, Anovas, correlations, the higher your sample size, the greater chance your results are going to be statistically significant. Whereas the lower your sample size is, the lower chance you're going to have of finding significant results. Therefore, when you increase your sample size, you are actually increasing the sensitivity of your statistical test in finding a statistically significant result. So typically, the more the merrier in this idea, and that the higher your sample size, you're more likely to find significant results. If you don't have a large enough sample, important differences or relationships may go undetected. Now, there is a caveat to this. You don't want to have a massive sample size as well. As I've given an example here of a logistic regression, this sample had 380,000 cases. So when you have a really large sample size, you're going to find significance almost for everything. Even the smallest effect is going to come out statistically significant, which is not ideal. You're then not able to parse out the important information. That's where power analysis comes into play, where it tells you the sweet spot for running a statistical analysis. It gives you the ideal sample size and the minimum target that you should aim for when running a inferential analysis. So what is statistical power? Statistical power is the probability of finding a statistically significant effect in your sample if that effect actually exists in the population. So the power is calculated through this formula here, which is 1 minus the type 2 error rate. Type 2 error refers to failing to detect an effect that actually exists. So it's a false negative result. The standard for statistical power is typically in the social sciences, it's 0.8, which is really a percentage. If you move that decimal over right twice, that refers to 80%. So what this means is that we want to have at least an 80% chance of finding statistical significance if that effect or difference does in fact exist. So a power analysis is an objective way of determining the appropriate sample size for research and for inferential analyses. Like I mentioned before, regressions, correlations, t-tests, things like that. So when you're running a power analysis, there are typically 4 to 5 components, depending on the analysis you're using, sometimes even fewer. It could be 2 to 3 components. So the sample size is calculated based on what analysis you're running. So whether that's a t-test, regression, correlation, Anova, things like that. And it's also contingent on your expected effect size. So effect size is telling you the magnitude of your relationship. When you're looking at an inferential analysis, it tells you the magnitude of that effect. What is the strength of that relationship? And that value, if you don't have previous literature in your topic to support what effect size to use, typically you go with a medium effect size. And I'll show you in G-Power, and there's a lot of resources on this, what is a small, medium, and large effect size. The third component is the significance level, and the fourth is the power level. So as I mentioned in the previous slide, we use a 0.8 in the social sciences. Likewise, with significance, this means what is the level to which we are defining significant results, meaning what does your p-value need to be lower than? 99% of the time, it's going to be 0.05. And that is meaning that p-values need to be below 0.05. And in the social sciences, this is what you will see a lot. However, if you're doing, there is that 1% of cases where maybe you're doing a Bonferroni correction, where you use the same analysis multiple times with the same variables. Maybe the same dependent variable is being used recurringly. So in that case, there's corrections you can do to reduce this alpha level. So if you're doing the same analysis twice with the same variables, the formula is taking your alpha level and dividing it by the number of times you're using that analysis. So it could be 0.05 divided by 2. So instead of 0.05, you're using 0.025 as a significance threshold. But that's rarely used. So there are 2 types of power analyses. We have a priori, which is basically the methodology phase, figuring out what sample size do you need to trust your findings when you run your analysis. So that's the a priori is the methodology-based power analysis, giving you the minimum target for your sample. Post hoc power analysis is done once you've collected your data and you've run your analyses, you've completed your data collection, and you're trying to figure out what is the achieved power of the analysis I just ran. So when doing a post hoc power analysis, you enter in the sample size, your final sample size. It's kind of doing the reverse of an a priori. So as I mentioned at the beginning of the presentation, there are several software packages that are available for conducting power analyses. The most common used today in schools is G-Power. I will show you a demonstration of G-Power and also Intellectus, which is our company software, which is much easier than G-Power. It's just point and click, and it will give you a full write-up for a power analysis. Really cool. So here are some links for downloading the software. The first link will take you to a website in which you can download G-Power, which is a really small software, only a few megabytes, I believe. And then the second link is a PDF document that goes into depth about what a power analysis is conducting in G-Power. What effect size should you use? How many groups are you comparing? It kind of gives demonstrations of different analyses. Okay, so I will start out by showing some examples in G-Power. I do see we have some questions coming through. I will address questions at the end of the presentation, the Q&A session. Okay, so this is what G-Power looks like when you first open it. And you will see there are 5 test families. So this is assuming you've figured out your research questions, you know what analysis you need to conduct to address those research questions, you know how many groups you're comparing, what are the variables of interest that you're looking for associations between. So we'll start out with some examples, some basic ones. So under exact, the exact test family, you will see the statistical tests that accompany us. And the first one is a bivariate normal model correlation. So this is a fancy title for a Pearson correlation. The same idea as a Pearson correlation. Let's look at that. And a Pearson correlation is used when you're looking at the association between 2 continuous variables. So the first thing you have to do is determine, are you looking at a one-tail test or a two-tail test? A one-tail test means that you're hypothesizing directionality between your variables. So for instance, say we're looking at relationship between job satisfaction and self-efficacy. And a one-tail test would mean that we hypothesize that as job satisfaction increases, self-efficacy is also going to increase, specifically increase. A two-tail test means we're not hypothesizing a direction. Maybe as job satisfaction increases, we're just anticipating that it's related to self-efficacy. So this would be a two-tail, and that we just are assuming that there's going to be a significant relationship between the variables, not necessarily as one increases, the other increases. When it's two-tail, one variable can increase and the second increases, or one variable can increase and the second decreases. So it can be a direct or indirect relationship. The next component is looking at the effect size. So as soon as you come into G-Power, it's going to give you a medium effect size here, which is 0.3. If you do some research online, you will see what is a small, medium, large effect for correlations. And then if you have literature in your topic to support using a small or large effect size, you can substitute that value here. If you don't have literature, then you just go with a medium effect size. The next component is our significance level. So what is the p-value for statistical significance? Then we look at power, which G-Power, when you first open it, is going to have 0.95. I always adjust this to 0.8. This is something that's done in the social sciences today. And this final box, we always leave as 0. We'll click calculate right here, and you'll see on the right parameter box, it's going to calculate the minimum sample that you should target to run this correlation. We need 84 participants as a minimum here, ideally, to run this test, and that's for a two-tail Pearson correlation. If you do a one-tail test, the sample size does decrease slightly. Okay, so you can go one-tail or two-tail. It's kind of a literature-based decision, and what are you anticipating to happen? Okay, and that can adjust your sample size. I'll show you an example of a t-test. So I'm going to the t-test family, say we're comparing between two independent groups. So I'll click down here and we have difference between two independent means, two groups. Same idea here. And as you can see, if you hover over this box, it works for some analyses and others it doesn't. It looks like it works for this one. It did not work for the correlation. If you hover over effect size, it will tell you what is a small, medium, and large effect size. So that's really useful. You can kind of experiment around with it. But like I said, if you don't have literature in your topic to tell you what effect size to use, I would just use a medium effect size. So here we have the same idea with the tails. For a t-test, we're looking at differences between two groups. Say we're looking at differences in self-efficacy between males and females. This is when you would do an independent sample t-test. So the tail idea is the same here. If you're hypothesizing that females have higher self-efficacy than males, that would be a one-tail test. But if you're hypothesizing that there's just a difference between males and females, you don't know which one is going to be higher, that's when you do a two-tail test instead. Okay, so the other parameters you keep the same. 0.05, you change power to 0.80, and you keep the allocation ratio at 1. So if we do a one-tail test, meaning we're hypothesizing directionality, ideally we need a sample size of about 102 participants. So dividing that in 2 would lead to 51 in each group. So 51 males, 51 females. If we do a two-tail test, that sample size increases to 128. It would be 64 males, 64 females. Okay, and another example under the t-test family would be matched pairs. So if you're doing a pre-test and a post-test, that would be this example right here, two dependent means. Okay, so let's just say for this example, we're anticipating a difference between pre-test and post-test for self-efficacy. We are anticipating self-efficacy is going to increase after an intervention of some sort. You would do a one-tail test. We have the effect size here, and you can see I'm hovering over the box right here, and it's not showing the small, medium, and large. So it does it for some analyses, others it doesn't. If it doesn't do it for a specific analysis, you'll have to look online to find what is a small, medium, large effect size. Again, we have power at 0.80. And this yields a sample of 27 participants for pre-post examination, meaning you need to match your participants. The same participants who take the pre-test need to come back and take the post-test. You would need 27. If you're doing a two-tail test, you would need 34. So another test family are F-tests. So this encompasses regressions and Anovas. So regressions are when you have prediction, right? You have a series of predictors predicting an outcome. Linear regression means it's going to be a continuous outcome. So here we have the effect size. I can hover over it this time and see that 0.15 is medium, and we have small and large there as well. We'll change the power to 0.8, and A regression is a little unique in that you can enter how many predictors you have. So once you're developing your research questions and you're figuring out how many independent variables am I using, how many predictors do I have, you can change that here. So the more predictors you add, the higher that sample size requirement is going to be. So 2 predictors yields 68. Say we do 5 predictors, that goes up to 92. So the more people or the more predictors you have, the more people you'll need as a result. Another example is a one-way Anova. So this is similar to a t-test, but we're looking for differences in the variable between multiple groups as opposed to just 2 groups. So an independent t-test, I gave the example of comparing males and females. Say we're looking at ethnicity or race, where we have white, black, Asian, Hispanic, and so forth. That's when you would do an ANOVA. So we have our effect size conventions. Alpha is the same, power will change, and the number of groups you're comparing. So in the example I just gave, how many ethnicity or ethnic groups do we have? Say we're comparing 4. That means you need about 180 people. You take that 180 and divide it by how many groups you have. So 180 divided by 4 is 45. So you need approximately 45 people in every group. Okay, so that's a demonstration in G-Power. This is our company software that we've developed called Intellectus. So Intellectus allows you to crunch numbers, present output. It's going to run analyses for you. You can see all the different analyses we have. We have several types of ANOVAs, t-tests, regressions, and all the data management functions that we have here. So in G-Power, we got a power analysis. We have our own power analysis software right here that will replicate what G-Power is giving you, and it's going to put it in a write-up. So the first example I showed you was a Pearson correlation. So if I just click Pearson correlation, it's going to give you 3 write-ups for a power analysis, depending on what effect size you were looking at. So if we're using a medium effect size, we need approximately 82 participants. If we're doing a t-test, we need, for a medium effect size, 128 participants. We did a regression, so a linear regression. And you can change the number of predictors up here for a regression. So if we did 5 predictors, we need about 92 people. And we did ANOVAs. So an ANOVA, say we had 4 groups of comparison, we need about 179 people. There's a slight rounding differentiation. It was 180 in G-Power, so this is 179. So very close. We also have data analysis plans in here. So this is kind of going back a step. Say you don't know what analysis you need to run. We have this decision tree that lets you pinpoint what variables you're looking at, continuous, nominal, ordinal, and it will guide you to the appropriate analysis, to which point you can then go into data analysis plans. And for instance, if we're doing a t-test, it gives you a sample research question along with the hypotheses, and it tells you what assumptions you need to check and so forth. Then you go to power analyses and you copy and paste your t-test write-up into your methodology. So it's pretty cool. All right, so that's the demo. So in summary, a power analysis is used to calculate and determine your minimum sample size for an inferential analysis. You first want to draft your research questions and hypotheses before you even think about running the power analysis, because you need to pinpoint how many variables you're looking at, what analysis are you running, what are your independent and dependent variables. Then you need to go through the literature and figure out what effect size you need, a medium, small, or large. Then you want to use G-Power or Intellectus to calculate that minimum sample size. So thanks for joining us today. That concludes our presentation. Just to reiterate that Statistics Solutions provides assistance with every part of the dissertation. I'll now be doing a Q&A session if you have any questions. I do see we have a few. You can contact us at info@statisticssolutions.com or give us a call at 727-442-4290. We will be sending everyone a copy of the presentation today, along with the recording of the webinar. So yeah, let us know if you have any questions. Let's check out what questions we have. All right, so we have a question from Sierra. I'm creating a measure assessment tool for my dissertation. What test and statistical test should I use? So if you're using potentially Likert scale questions, you might need to do an exploratory factor analysis or a confirmatory factor analysis. Those are called EFAs and CFAs for short. If you look online and you do there isn't really a power analysis for that, unfortunately. There's rule of thumbs. So depending on how many items you have, you need to have a certain number of people. Usually when doing an EFA or a CFA, I've seen people target around 200 people when developing your own tool, because you have to prove that that tool is reliable and valid. So there isn't a power analysis for this, but you'll see that there are citations that tell you what sample size you need for an EFA or a CFA. That's what I would check out online. We have a question from Anthony. Would a study where the overall population is less than 200 affect the application of this type of power analysis? Potentially, yeah, that's a good question. So it really comes down to what analysis you're using and how many people you do expect to sample from. If your sample is less, or your population is less than 200, it's going to be a limitation, I think, if you don't anticipate collecting data from everybody. I think it's going to be a limitation for the sample size, at which point you can still proceed with the analysis, which happens 90% of the time, especially during this last year with the COVID pandemic. I've seen a lot of studies that don't reach that sample size requirement. All you have to do is just interpret your results with caution. Your analysis is going to be underpowered, but it's just something that you present your results and you interpret those results with a level of caution. Okay, we have a question from an anonymous attendee. How does it address moderation under regression? That's also a really good question. So moderation is based on a multiple regression. So you need to look at how many predictors you have and how many moderators you have. So when you test for moderation, you typically make interaction terms, which is just multiplying your predictor times your moderator. So that counts as a predictor. You have your predictor, you have your moderator, and you have your interaction term. Right there, you have at least 3 predictors, or 3 independent variables, I should say. So if you add more predictors or you add more moderators, then you have more interaction terms. So at a minimum, you have 3. But as you add more predictors and moderators, that number goes up. And then you just use the power analysis right here you would use a linear regression. So this option here, you could just enter how many predictors you have, which would be adding up your key predictors, your moderators, and your interaction terms. All right, we have a question. Are there any special considerations if you plan to use MTurk to get more participants to meet your power? Special considerations? I don't think so, really. If you're just using it to get more participants, then that's great. Maybe you're slightly below your sample size requirement and you're using Amazon MTurk to gain more responses. There isn't much more to it. You're strengthening the power for your study, which is a really good thing. We have a question from Anthony. What is the cost of requesting your service? Looks like, I think Melissa is going to respond to that question. But if you have questions about cost, you can email us right here at info@statisticsolutions.com or give us a call for a free consultation, and our specialist will talk to you and discuss where you need assistance and provide a quote. The question from Janet: are there any special considerations if one is working with secondary data? Wow, we have really good questions today. When you do a power analysis, it doesn't really matter if you're doing it with a survey or if you're using secondary data. The sample size requirement is 100% contingent on what analysis you're running. So I would say no, there isn't really a special consideration to working with secondary data. You do the power analysis the same way, regardless of administering a survey or collecting archival data. It's going to be the same process. All right, let's see. Thanks everyone for joining. Do all moderations require 200 participants? No. So we had a question about this just a few minutes ago, that it's based on a regression model. So moderation and mediation, kind of the same idea. You have multiple steps in a regression model. So moderation specifically, you have predictors, you have potential moderators, and you have interaction effects. So you need to count all of those up. And in GPower, use this box to enter the total number of predictors. Okay. Do we have any other questions? Really good questions. We will be sending everyone a copy of the webinar. And check out our future webinars as well. We're doing approximately 8 webinars a month, covering every topic. So if you're in the methodology or the literature review or the introduction, we have a webinar for that specific chapter. So if you've hit a roadblock, I would definitely recommend joining those webinars. Melissa just put the link to upcoming webinars in the chat box, so you can check those out. As you can see, it looks like we're scheduled in June coming up. So we're discussing qualitative results. We have a discussion chapter component, qualitative methodologies, presenting a quantitative results chapter, mastering a literature review. I will be doing this webinar here about importing data into SPSS, and I'll discuss data cleaning and management. So we have a lot of webinars on the horizon. Do we have any final questions? I'll stay on for a few more minutes. Any final questions? All right. Well, thank you for joining us, everyone. Let us know if you have any questions about the services. Melissa did provide the link in the chat box to which you can schedule a free consultation. And as always, stay safe and come join us for a future webinar. Have a great evening.